Okay, final video for tonight. These are the answers to the synthesis problems that I sent earlier today and went over last night in SI as well. So I tried to add a couple things here, different types of synthesis. The first one being how do we add a long alkyl chain? I talked about this in the first video, is that we use acylation here, okay? If we were to do alkylation, we're gonna have some type of rearrangement, we get something else. So I made sure to do acylation, and then I used a reduction method to do that. I went ahead and used Wolff-Kishner here, okay? Whether you need all the other fancy stuff with it, synthesis usually not, but just in case. Okay, so here I'm adding my acyl group, and here I'm just taking that ketone and taking that off. I'm left with my long alkyl chain. Also, benzoic position. Also notice that in our product here, we're making our conjugate system larger, so that's a good, useful, maybe synthesis problem. So to do that, first thing I did was I did bromination. Okay, so I put bromine right here. I made a Grignard, which is typically what follows bromination. That benzene here as a nucleophile then had to attack this group here, propanal. Okay, bumped up those electrons on oxygen, and then which it then protonated. It has no good leading group, so it protonated. I now have an OH group in the benzoylic position. I need to turn into a double bond. How do I do that? I use sulfuric acid. Okay. I could have also, I guess, turned that OH group into BR using PBr3, and then doing some type of elimination reaction to get that as well. You could maybe even do some sort of Wittig reagent, but there's no reason to do that. It's just complicates things. Maybe you would, I don't know, I'd have to try it. Anyway, so covers like alkylation and acylation. This covers bromination and Grignard reagents. This one down here is then takes our last route of that diazonium ion. So I see cyanide here. I should know that cyanide is one of those groups that diazonium ion can then turn into, because it's really a living group. Okay. So how do I get there? I need to do nitration. I need to reduce that to an amine. Likewise here, I could have instead used HCl and some type of iron or tin catalyst. So I have an amine here now. I turn that amine into that diazonium ion. I do that using sodium nitrite and HBr. Now I can use copper cyanide to go ahead and replace that. And this step, if I had OH here, I could use water and those copper compounds. If I had bromine, I could use copper bromine, and so on. Okay, so last step can be a ton of different things when we use the benzene diazonium ion. 3 different synthesis problems here that demonstrate different things. I hope some of this will be useful on the assessment tomorrow. I imagine some of it has to be to some extent. Hopefully you're staying up late and this video helps, or you wake up early and want to knock 24 out of the park, which I think you will. I think it's an easier chapter, and good luck to you all. See you all in class tomorrow.